to simplify the following square roots. Looking at the radicands, or numbers under these square roots, notice how they are not perfect squares. This does not mean the square roots will not simplify, it just means they will not simplify perfectly. A square root will simplify if the radicand contains any perfect square factors. So in the previous lesson we learned that for a non-negative real number a, the square root of a squared is equal to a. For example, the square root of 25 is equal to the square root of 5 times 5, which equals the square root of 5 squared, which simplifies to 1 factor of 5. This simplified perfectly because 25 is a perfect square. But again, a square root will simplify as long as it contains perfect square factors. So if we look at the square root of 45, the prime factorization of 45 is 3 times 3 times 5. Because we have two factors of 3 here, 45 does contain a perfect square factor, and therefore this will simplify. The square root of 3 times 3 times 5 equals the square root of 3 squared times 5, and from here we use the product rule for square roots, which states we can write the square root of a product as a product of two square roots. So this square root is equal to the square root of 3 squared times the square root of 5. The square root of 3 squared simplifies perfectly to 1 factor of 3, and therefore the square root of 45 simplifies to 3 square root 5. Let's go back and look at our examples. The square root of 8 will simplify if 8 contains any perfect square factors. So let's look at the prime factorization of 8. The prime factorization of 8 is 2 times 2 times 2. Notice how we do have two equal factors here. 2 times 2 is 4. 4 is a perfect square factor of 8, and therefore this does simplify. This is equal to the square root of 2 squared times 2, which we can write as the square root of 2 squared times the square root of 2. The square root of 2 squared simplifies to 1 factor of 2. The square root of 8 simplifies to 2 square root 2. Now let's simplify the square root of 48. The square root of 48 will simplify if 48 contains any perfect square factors. Now if we know our perfect squares and recognize that 48 is equal to 16 times 3, we can save ourselves some work. We can write the square root of 48 equals the square root of 16 times 3. 16 is a perfect square. This is equal to the square root of 4 squared times 3, which equals the square root of 4 squared times the square root of 3. And the square root of 4 squared simplifies to 1 factor of 4. This simplifies to 4 square root 3. But if we don't recognize that 16 is a perfect square factor of 48, we would look at the prime factorization of 48. So let's also do that. 48 is equal to 6 times 8. 6 is equal to 2 times 3. 8 is equal to 2 times 4, and 4 is equal to 2 times 2. The prime factorization of 48 is equal to 4 factors of 2 and a factor of 3. Again, anytime we have two equal factors, we have a perfect square factor. So here's a perfect square factor, as well as here. So this is equal to the square root of 2 squared times 2 squared times 3. Now we'll write this as a product of 3 square roots. This equals the square root of 2 squared times the square root of 2 squared times the square root of 3. The square root of 2 squared simplifies perfectly to 1 factor of 2. So we have 2 times square root 3, which equals 4 square root 3. After we do this a while, we can probably go from this step here to the simplified square root, but for these examples, I will show this detailed work. Next we have the square root of 150. Let's look at the prime factorization of 150. 150 is equal to 3 times 50. 50 equals 5 times 10. 10 is equal to 2 times 5. So the prime factorization of 150 is 2 times 3 times 5 times 5. 5 times 5 is a perfect square factor of 150, so this will simplify. Let's change the order of this multiplication. Let's write 5 times 5 as 5 squared. So we have 5 squared times 2 times 3, which is equal to the square root of 5 squared times the square root of 2 times 3. The square root of 5 squared simplifies to 1 factor of 5, and therefore this is equal to 5 times the square root of 6. So square root 150 simplifies to 5 square root 6. For our last example, we have the square root of 1,350. Let's look at the prime factorization of 1,350. This ends in 0, so it's equal to 10 times 135. 10 is equal to 2 times 5. 135 is equal to 5 times 27. 27 equals 9 times 3, and 9 equals 3 times 3. So we have a factor of 2, 3 factors of 3, and 2 factors of 5. 2 times 3 times 3 times 3 times 5 times 5. 3 times 3 is a perfect square factor of 1,350, and so is 5 times 5. Let's go ahead and write this as the square root of 3 squared times 5 squared times 2 times 3, which is equal to the square root of 3 squared times the square root of 5 squared times the square root of 2 times 3. Well, the square root of 3 squared is equal to 3. The square root of 5 squared is equal to 5. And this is still square root 6. 3 times 5 is equal to 15, and therefore this simplifies to 15 square root 6. 15 square root 6 is a simplified form of the square root of 1,350. I hope you found this helpful.